Okay, well, thank you very much, everybody. Great to be here at 10 o'clock in the evening. So I'm going to talk about the Eagle deposit, but from a structural point of view. And I'm going to be presenting work primarily carried out by Harry Madeley, who was a PhD student who unfortunately, or fortunately for him, decided to transition into industry. I'd also like to acknowledge the support of Lundin Mining and specifically Bob Mahan and his team at Eagle Mine Exploration. So we've already had a couple of talks with about the setting of Eagle, so I don't feel I need to go into this in a great deal of detail, other than to say that the Eagle deposit is situated in the Barriga Basin, which is a foreland basin to the Pinocchio orogeny to the south here. So it's host rocks are about 1.85 million years old. So that's a close-up of the local geology of the Barriga Basin. Those are the two peridotite bodies, originally known as the red dog peridotites, and they're situated in the Barriga Basin here. And as we heard before, they're about 1107 million years old. In terms of the structure of the Barriga Basin, we're looking at an asymmetric syncline, and the Eagle system is situated on the northern limb of that syncline. Just double checking that everything's working here. Can everybody see and hear me?
Yes, yeah.
Okay, sorry, I can't see myself, which is weird. Okay, so in terms of the architecture, we're looking at two rather low width to length aspect ratio dikes in plan view. And specifically, the Eagle intrusion is about 400 meters long, 1 to 200 meters wide, and about 300 meters deep. And Eagle East is bigger. It's around 1.5 kilometers long, 50 to 250 meters wide, and 1,200 meters deep. But when we look at them in long section, we've already seen a similar figure to this. We see there's actually quite a lot of complexity in the architecture. And we could describe the Eagle intrusion as a flattened keel-shaped bowl. And Eagle East is really quite a complex beast. It comprises a sort of anvil-shaped dike at the top. You see a narrowing at a stratigraphic boundary at depth, and it goes into a sub-horizontal flattened channelith, also at a stratigraphic boundary. And then we have this strange gabbro plug, which we know to be younger in age, which is probably following the original feeder to the ultramafic rocks. In terms of the 3D structure and mineralization, so here we have a leapfrog model of Eagle. We see that it has a blade shape morphology and cross-section. Disseminated mineralization occurs in the center, and massive sulfide mineralization is concentrated at depth, and is particularly concentrated on the lower side of the dike. And we also see ingress of massive sulfide mineralization into the host rocks, which we'll talk about in a minute. In terms of Eagle East and its 3D structure, so here we're looking at a section roughly, well, exactly through that location there. It's also a blade-like channel, but it has a teardrop cross-section. Again, disseminated mineralization is in the center. And then we have massive sulfide mineralization concentrated in a flattened tube-like ore body. And again, evidence for ingress into host rocks. Now, one of our key goals was to undertake a structural analysis of the host rocks to see if there were host rock structural controls. So in terms of the regional structural geology, this is a compilation of bedding and cleavage measurements for the entire Barriga Basin. And just to, I know all of you hate stereo nets. We're dealing with a situation with open asymmetric folds with shallow south dipping limbs and steeper north dipping limbs and a moderately to steeply dipping axial plane cleavage. So that pretty much reflects the cross section that we just saw a few slides ago. And then we undertook a great deal of work with oriented core at Eagle. There were multiple issues with misoriented core, but we developed a workflow to correct and censor measurements to end up with very nice, well-behaved data sets for each drill hole. So here we have drill hole 338. And this is the summary of all the data, the structural data from the regional scale to Eagle East. And Eagle has a very consistent, almost shallow, flat-lying bedding, moderately inclined cleavage. Eagle East has a lot more variability in bedding, so there's a lot more folding going on at Eagle East, and again, a moderately inclined cleavage. In terms of structural models for Eagle and Eagle East, starting with Eagle, here we're looking at leapfrog models at top, the plan view, and at bottom, cross sections. And what these are essentially telling us is that the Eagle dike is parallel to the traces of the local cleavage form lines. So there's some strong indication of structural control there. And then if we look at it in cross section, you can see how these sill-like bodies are sticking out outside of the host peridotite into the host rocks, and they're following the form lines of bedding. So again, very strong local structural control of mineralization and the host peridotite body. Similar story at Eagle East. We see here in the plan view image, the host at Eagle East is parallel to the local cleavage form lines. We see in cross section that the ore body, in this 3D model, the ore body is parallel to bedding cleavage intersection and host rock fold axes, and that we see these similar ore bodies forming protuberances into the host rocks that follow bedding form lines. An interesting story about Eagle and Eagle East are breccias. At Eagle, we see a particular type of breccia that looks like this, mapped as an igneous breccia, where we see fine-grained peridotite clasts in a coarser-grained peridotite and disseminated sulfide matrix. In the host rocks, we see evidence for high-grade metamorphism in the form of cordierite porphyroblasts and minimum melt patches. And we think that what this suggests is that we have evidence for either collapsed chilled margins, a la the Barnes and Mungal model, and or thermomechanical erosion at Eagle. At Eagle East, the breccia story is quite different. The marginal zones at Eagle East are characterized by hornfels breccias, like these ones you see on the left. And these are intimately associated with an early fine-grained peridotite phase. And we think that this suggests that there may be an early hydrothermal dike or pipe event followed by initial intrusion of the fine-grained peridotite phase at Eagle East. We also note that the hornfels breccias were preferential sites for downward migration of sulfide liquids at later stages in the evolution. Okay, so coming to an emplacement model for the Eagle system, this is what we're currently thinking. We think that the Eagle and Eagle East were once connected, and they represented a bladed dike with a complex feeder at depth. And what we're looking at here is a transition from essentially vertical transport to lateral transport, probably related to either a stress barrier or some kind of increased surface load, possibly related to a shield volcano above the system. And we see this sort of thing at many volcanic complexes, for example, in Hawaii. The Eagle intrusion and ore body looks like it was initially an undulation at the base of a laterally propagating dike that was probably deepened by thermomechanical erosion and quite likely also sulfide melting. And the evidence for that are the high temperatures recorded in the wall rocks and the igneous breccias. The Eagle ore body itself likely represents the downward accumulation of sulfides as well as ingress into the host rocks. And as we've seen, there's actually a strong structural control at that scale. Eagle East may well be part of a precursor hydrothermal breccia dike represented by the Hornfels breccia phase that we talked about earlier. The Eagle East ore body itself looks like it was trapped in a narrow, structurally controlled horizontal conduit. So to conclude my talk, I think I'm not going to read all the text here. I'm just going to leave you with this thought of this lovely yacht that we saw last summer in the parking lot at Marquette, just about to head out into Lake Superior. But it's a beautiful analog for Eagle West, or the Eagle itself, and probably not Eagle East. And that's the end of my presentation, and thank you for your attention.